the name of the values that keep you alive. Do not let your vision of man be distorted by the ugly, the cowardly, the mindless, and those who have never achieved his title. Do not lose your knowledge that man's proper estate is an upright posture, an intransigent mind, and a step that travels on limited roads. Do not let your fire go out. Spark might replace the spark, and the hopeless swamps of the approximate, the not quite, the not yet, the not at all. The world you desired can be won. It exists. It is real. It is possible. It's yours.
Hey guys, welcome back to the Crypto Economy Podcast. I'm really excited today to have a representative from Helium here. So I just want to welcome Frank to the podcast. Thanks for being here.
Hi, Mark. This is Frank. Thanks for having me. It's great to be on your show.
Great. Well, this was sort of an unusual podcast. I reached out to these guys because I was really interested in what they're doing. I love the hardware component. I love what they've done with sort of the infrastructure and how they're going to market. So I wanted to introduce them to you guys and have them tell you a little bit about themselves. So to get started, what are sort of the current problems with getting Wi-Fi or internet via typical ISPs, and how is Helium helping to solve this?
You know, I think this is a nice question that I think allows me to talk about why Helium even exists. The premise in which we started the company, which is 7 years ago, I guess, in 2013, Sean Fanning of Napster and Amir Helium decided to start Helium to solve a problem of an unmet need to connect Internet of Things to the Internet, because cellular carriers like the AT&Ts and the Verizons of the world did not really have the business model to support little devices like we're talking temperature sensors, or we're talking GPS tracking devices for dogs and cats, let's say. There was not the right sort of business and economic model to support small little data plans for small little things. And so hence Helium decided to attack this market and say, hey, let's go build a network that connects Internet of Things and small little things ubiquitously to the Internet in a very easy and affordable way.
So when you talk about sort of affordability, what is your strategy to make this affordable? Is it affordable to people yet, or is this more of a in 10 years it should be affordable and ubiquitous kind of thing?
So there's two parts to this, and one of which relates to the blockchain and the Helium network and the Helium hotspot. And then there's a second part, which is all the little devices that are out there that would connect. How much would it cost them to connect? So I'll answer those two parts. Is that okay?
Yep, that sounds great.
Great. So on the first part, to build a network and network infrastructure in the traditional way, the way our telco carriers do it, is very expensive. It's billions and billions of dollars, and takes years to build out, like cell towers as an example, to get cellular coverage in your area. It took a long time, and it's expensive to do so. And so Helium as a company said, all right, well, we're not going to go raise billions of dollars of venture capital funds and take 10, 20 years to go build another network, that someone's already spent a lot of time doing with cellular. Instead, 2 years ago, we said we're going to leverage something called a blockchain. And what we're going to do is we're going to create our own blockchain that allows us to create an incentive model for individuals and consumers to become the telco, essentially to own and operate their own Helium hotspot. And that Helium hotspot would connect to their home Wi-Fi and allow that hotspot connecting to the home Wi-Fi to use something called 900 megahertz, which is a open public spectrum in the United States. And that spectrum and that technology has characteristics that's more attuned to small Internet of Things devices, in that it has range for miles and miles. So when I say range for miles and miles, meaning that little hotspot in your home from Helium can hear a little sensor from up to 25 miles away in the most ideal situation. And in dense city environments like Manhattan or San Francisco, it has range of a mile or two. You have to go through a lot of buildings. But the characteristics that are good there is that this signal tends to go through concrete really well, which is very different and better than your traditional Wi-Fi, Bluetooth, and cellular technology. The characteristic also, it lends itself to have really good battery life. So unlike our mobile smartphones, whether it's on Android or iPhone, the batteries, typically last a day. Well, in our case, for small sensors out there using 900 megahertz in this public spectrum, the devices can have battery life up to 3 years. So these are really good characteristics for Internet of Things that could live outside, right? Outside of your home and outside of your office. So that's one aspect of where this is really useful. And the other aspect is on the usage side, cost-wise. If the cost of building a network was co-opted to consumers and individuals, then the cost of using a network can also be spread across, multiple devices and multiple people. So by and large, what we're seeing is that cost for using the Helium network built by individuals, we call it the People's Network, by the way, could be as low as $2 to $10 a year per sensor. And that's a huge difference in what you and I pay for our cell phone plans, right? I don't know about you, but I pay like $100 a month so I can surf, YouTube and
least.
Instagram. Yeah, at least, right? But in our world, we're not surfing YouTube and checking on Instagram. It's for temperature readings and GPS readings and status updates and maybe some text message, but that would be it. It's small bandwidth, small amounts of data.
Can you tell me a little bit about the sort of public bandwidth signal that you guys are utilizing and why that matters in the marketplace? So what sort of the existing model would be for ISPs or providers trying to use that and how you guys are leveraging the public channels?
Sure. This public spectrum I'm talking about is called 900 megahertz. It's an ISM band. In the world of radio waves, that's what it is. It's a low frequency signal. Folks that are like from the old days of ham operator radios, they kind of understand this. But the spectrum is actually it's a broad spectrum, low frequency, which means that it's actually much more attuned to what you see in nature. The signal wave is all around us essentially. And so it is quite noisy because it is public, meaning anyone can use it. Right? It's free to use. So it can get quite noisy. And where Helium adds value to that is our ability to filter through all the noise, and what we call in our radio world channel hopping helps so that we don't lose signal or lose packets. But those are the elements in which a public spectrum operates within, versus in the cellular technology world or Wi-Fi or Bluetooth. They tend to operate on licensed spectrum, which are both unlicensed or public, and licensed are managed by the FCC. And so we have to abide by the FCC guidelines. It's very well regulated. But in either case, one is licensed, one is not. We're using the unlicensed public version versus Wi-Fi, cell, Bluetooth.
And it's not cheap to buy the licenses either from the government, right?
No, it's very expensive. And what happens is conglomerates or standards bodies, they tend to tackle that. They'll buy those spectrums, or large centralized entities like AT&T and T-Mobile, and even Comcast and Google actually got into the game. They'll buy spectrum because radio frequencies and certain licensed spectrums could be valuable.
Yeah, or if you're Sprint, you'll just merge with T-Mobile to get a little
That's
extra, right?
Oh,
yeah, that makes sense. So, do you think it's sort of realistic that one of these hotspots, I know you've mentioned, can power like 1.5 million devices? What's the spread of these throughout a city that you would need to realistically have full coverage? So I looked in DC, I noticed there are, I think, like 30 other hotspots, but some are, pretty far away. So if I'm looking at buying one of these hotspots, what's that number that I'm looking for to have some real coverage? And how are you strategizing to get coverage across the wider U.S.?
Yeah, so on the coverage front, I would say in a typical U.S. city, you probably need anywhere from 50 to 100 hotspots to have coverage within that city that's comparable to cellular coverage, let's say. In unique situations like Manhattan, where it's super dense, tons of buildings, you might need 300 hotspots to cover all of Manhattan. And so I know you mentioned Washington, D.C. If you go to network.helium.com, it's open to anyone, so anyone can go check it out. You can see sort of how many hotspots are within your city. Today we're in, for example, 745 cities across the U.S., and so you can kind of see that Manhattan's got, I think, close to 300 hotspots. San Francisco's over 300 hotspots, and we've got some interesting situations happening in Modesto, California, where they've got 200 plus hotspots. And
That's funny. I have family in Modesto.
oh, do you? We got
Yeah.
Birmingham, Alabama, or Atlanta, Georgia, with 200 some odd hotspots, and Chicago with getting close to 200. So, depending on what city you're in, you're going to see, again, early adopters, whether it be interested in the Internet of Things and building a network, or folks that are trying to solve potential business problems or use cases, maybe like in Modesto, because there's lots of farming out there. Could be a large farming use case out there. But that's that's what typically drives deployment of the Helium hotspot today. And I think the other
Are there does
around,
the speed? Sorry. Go ahead and answer the second question first.
Sorry, the other part of your question was related to number of devices that can connect to one hotspot, and I think it really varies. I think it doesn't work the same way as how our laptops and our smartphones connect to cellular towers, in that when your phone is on, it's consistently connected to a cell tower all the time. And even if you're just, you have your phone on your desk and you're not actually making any calls or using it, your phone is actually sending information to a cell tower and then receiving that back in every millisecond. It's just constantly happening. And in that case, it puts a lot of it's a lot of burden and a lot of transactions happening for that cell tower. So if you're in a town where there's a million people using that cell tower, then that cell tower is going to get really busy, and so that's not great. In our world, the way that public open spectrum of the 900 megahertz work is that we don't maintain that session, meaning when your device is not busy or doesn't need to talk, it will not transmit, and that the hotspot doesn't need to always hear it either. And so we're not maintaining this session. We're not taxing the network or the hotspot. So if you've got a million devices out there and they're all trying to transmit, what's likely to happen is that they will burst those transactions, and it's pinging in a sense, intermittently, and so you're not going to get a bombardment of a million sensors or devices talking at the same time. They tend to be staggered. And even if they're staggered in nanoseconds or milliseconds, that's fine. So it scales.
Yep, I rented one of those bird scooters and I just took it home over the weekend. It's like a monthly rental, and just by the nature of it pinging location all weekend, it went from 100% to 0. And you're talking about a scooter running, actual batteries in there. So it's killing battery life too.
That's right.
My sort of follow-up question was how the network scales. So does it scale as far as speed to connection proportionately with the number of hotspots, or is it pretty sort of capped just on one hotspot?
Yeah, so when you think scaling in our world, it's really about coverage and whether or not a hotspot happens to be close enough to hear your bird scooter or your dog's collar, and that is the metric in how we look at our network. The speeds of our network is not, it's real time, it's in milliseconds. So as an example, if the bird scooter used the Helium network, it can provide location every 5 seconds or every minute, and as soon as it transmits, meaning it says, hey, I'm here, here in Washington, D.C., the owner of that scooter, in this case Bird or some other company, they'll get that information in near real time, almost instantaneously. And so speed isn't the issue. I think the big distinction for folks to understand is the bandwidth, right? And so I think in today's world, when you and I surf the internet, we're on 100 megs or 200 megs or a gig of speed, right, onto the internet, and we're watching Netflix and YouTube TV and all that, which requires that kind of speed. In the Internet of Things world, for little things like a Bird scooter, for example, I'll just keep using that example that you mentioned, it doesn't need that speed, right? So we're talking about, we use 24 bytes to 20 kilobytes of data speeds, and that's more attuned to finding your dog or finding a scooter. And if that's too abstract, I think a good way to think about it is like a text message. Like when you send a text message to a friend, they get it right away, but that text message uses very little data. Could be 24 bytes to 20 kilobytes, essentially.
Yeah. So when you're talking about sort of passing this data in between devices, do you guys have security protocols in place so that the data is like encrypted, or how is the data transferred between the network? Is there some security in place?
Yeah, there's the security is built in two different ways, and I would argue it's much more secure than traditional networks. One, it's hardware encrypted at the sensor. So going back to the case of the scooter was running a Helium compatible hardware or transmission or sensor. The hardware, there's a hardware chip in there that encrypts the data right away, and that data is encrypted while it's being transmitted. It stays encrypted going through a person's hotspot, and it stays encrypted until it reaches the owner of the data's cloud environment, and then that owner is the only person with the keys to unencrypt that data packet. So data encryption is a key part of this. The second part is the blockchain itself, and the blockchain, how it enables encryption to occur the entire time without the need to inspect the data at all, is with something we called an OUI, which is an organizational unique ID. And so if Mark, for example, you have a business of like 1,000 scooters, right? It's Mark's scooter sharing company. What you would do is you would deploy 1,000 scooters with the Helium sensors on it, and you would have an OUI or organizational unique ID, and it might be MAR1 or Mark1, MARK1, and that's your OUI. And so as soon as a sensor or scooter talks in the DC area, hits somebody else's hotspot, the blockchain will see that the encrypted packet has a header called Mark1 and know exactly where to send that data. It's fully encrypted, and it sends it over to Mark1's Google Cloud Platform or your AWS instance, and then you get your data. So the combination of the blockchain as well as our encryption scheme really secures that information for you.
So to kind of take this full circle, how do the sort of Helium, the actual hardware, the nodes, how do those interact with the blockchain, and what's the perk of buying one now?
Yeah, so every Helium hotspot is a full node on the blockchain. What that means is you buy a Helium hotspot, you plug it in, connect it to your Wi-Fi, and turn it, go through the steps on the app to install it. The first thing it's going to do is it's going to download the entire blockchain onto your hotspot. And that process is important because it allows your hotspot to have an equal chance of joining the consensus group of our blockchain as anyone else. We don't have a concept. In some blockchains, there's concepts of who can actually be consensus. They have to be a trusted consensus group or some kind of master node of some type. In our architecture, I think we're probably one of the most democratic consensus forms or algorithms out there, in that every hotspot has an equal chance of joining and participating as a consensus group member. And the consensus group member changes. it constantly changes every 30 blocks or so, a new group is elected. And so depending on how long each block takes, it could be 30 minutes, it could be 60 minutes, but a new group election occurs. So getting the full node onto the hotspot, crucial. Giving every individual or every hotspot owner a chance to be a part of a consensus group, I think, is really important for our network's value, I think. And it's built for consumers. So we've built this hotspot so that it is that easy to get up and running. Think of it as like we want our user experience to be like the Apple of blockchain, right? So you need a hotspot, you need to plug it in with power, you need to know how to connect it to your Wi-Fi, and download the Helium app from iTunes or the Play Store, and off you go. Pretty simple.
Yeah, it's really beautifully designed as a product. I fell in love with it because it's just so cleanly built, and it's not easy to get something in front of the average Joe that they can understand and quickly set up out of the box. And I think the hardware is a great differentiator there too, because not a lot of crypto companies do hardware well, and I think it makes it a lot more approachable to people who are used to plugging in a box.
Thank you.
So.
Yeah.
Taking that another step further, how exactly are the tokens awarded? I mean, you kind of touched on this. So are users joining mining pools, and are these pools deciding rewards based on like location, for example, or is there some sort of mechanism in place to reward people who are in regions that are seeing a lot of traffic and rewarding them proportionally to traffic? So how are the incentives and the economics set up essentially?
Yeah, so the mining is, I think, pretty simple in that there's really 4 parts to mining, and 3 of them are geared towards proving that you have a reliable and secure hotspot that's real, and it's in the location you claim to be. And so that part of it is one part of mining. The other part is providing transmission and successfully transmitting data from a Internet of Things sensor back to the sensor's owner. And so providing that transmission over the internet is another part of mining. So those are two parts to it. The part about proving that your hotspot is located where you claim it is, and that it's available and secure, is broken down, I think, into 3 key parts. There in our blockchain, we have something called a proof of coverage, kind of analogous to proof of work in Bitcoin. And proof of coverage is really meant to solve the problem of building a network through disparate parties and allowing anonymous disparate parties to essentially work together to create a mass network. It doesn't matter if you're in a city or town or if you're by yourself. So we don't have that distinction. So to answer that part of the question, there's no mining pools, there's no cities or groups with priority. Our goal is to build a vast and propagated wireless network. And so this is where the peer-to-peer aspect of our technology comes in. So what happens is if you're a hotspot in, I'll use San Francisco because I know San Francisco the best. If you're a hotspot in downtown San Francisco by Salesforce Tower, let's say, and you want to prove yourself to the blockchain and to the network that you are near Salesforce Tower and you're providing coverage, the way you do that is that the hotspot would try to connect in a peer-to-peer manner to another hotspot within its range. And that could be a mile away, it could be half a mile away, it could be across the street. And the reason that's important is because it's going to want to be part of what we call proof of coverage, in which case hotspots are challenged by a challenger hotspot. And that could be located anywhere in the world. And a challenge, what we call a challenge packet, is issued over the internet. So let's say I have 3 or 4 hotspots in San Francisco with my friends. And Mark, I think you're in Washington D.C., right?
Yeah, I'm in DC.
Yeah, so if you have a hotspot in DC, your DC hotspot would issue a challenge packet and to one of my hotspots near Salesforce Tower, and your challenge would be constructed such that my hotspot would receive it encrypted packet from you. My hotspot would be the only hotspot that can unpack the data, and then it would give me instructions to send that packet to some other hotspot nearby, near me. And it could be someone that hotspot that's half a block away or a mile away or 2 miles away. And my hotspot would use the 900 megahertz radio and send that packet over the radio waves to hotspot number two. And then hotspot number two, if they receive the packet, they would open the packet with the key, and there would be instructions there for it to send it to hotspot number three, which could be another 2 miles or 3 miles away from that hotspot. And that's what we call proof of coverage, where these hotspots are proving themselves. And that's a way in which hotspots can earn cryptocurrency or mine the Helium token is by going through proof of coverage. And I mentioned something called a challenger, a challenger would be a hotspot. In this case, the Washington D.C. hotspot, Mark, the one you have, has created that challenge packet, and for successfully creating that packet and for it to be used in a proof of coverage system, you mine some cryptocurrency, and so there's a percentage of that that you're mining, percentage for the proof of coverage participants to be mining, and then the consensus group who are building the blocks from these results, they earn cryptocurrency or they mine the Helium token in that process as well. So those are the three key ways in which they're mining from just a pure hotspot proving that they are available and they are secure and they are where they're claimed to be.
Gotcha. That was perfect. So I know the hotspots themselves are not, super cheap right now. I think they're about $500. Is that right?
Yeah, so they were $500.
Yep.
We've sold out of the batch. They were fairly expensive because we didn't forecast for large production runs. We simply did not know what the demand would be, and so by building in smaller quantities and building them in the United States, the costs are high, and I've heard that feedback from a lot of our consumers. It is expensive at $495.
Do you know when sort of the break-even point might be for someone? Do you have any projections on things like that?
We don't. It's hard to say because there's a lot of there's some variables that go into that. But as I mentioned before, the mining process is well defined, and depending on how close you are to another hotspot or how far away you are, that's going to dictate whether or not you're elected in the consensus groups, if you can join a proof of coverage system as a participant, and if you're challenging the blockchain itself. Those are all variables that I think any hotspot host can try to figure out and play with, and it varies. So it's really difficult for me to say how
Sure.
much a hotspot's going to mine.
Yeah, no, I totally understand that. So on the tail end of that, how hard was it to design and develop the hotspots themselves, especially getting them manufactured in America?
So yeah, it was very difficult, I think, for any startup to build hardware. I think there's a lot of nuance and details that make it hard in the beginning, and a lot of lessons learned, a lot of mistakes made. But I think out of that, we've learned now how to actually scale this and be able to build tens of thousands of units, which is what we're doing for our May delivery. And so if you order from our website now, the hotspots prices are greatly reduced to $350 for folks that are willing to wait till May. And that's a direct result of all the learnings all the strides we've made and progress we've made on making manufacturing more streamlined, ordering more units, understanding how to build hardware at a much more efficient pace. And so those are all positives, I think. And any of the savings that we see from that, we pass to all of our customers. We open source all of this technology, Mark. So our goal isn't to build hotspots and to make money off of that. Our goal is to build a network really fast, and even faster than what we've already achieved, and have everyone, anyone really, to be able to build hotspots on their own and build applications and use this network. So everything's open sourced, and we hope someday that happens, where there's an ecosystem of just lots of people building this stuff. Would be great.
Yeah, it gets a lot cheaper after you build it the first time, luckily. So.
Of course. Yeah.
So, are you focused mainly on selling these in the United States? Are there plans to go more international? Is there sort of demand internationally? What's your strategy as far as expansion?
Yeah, there's two parts to this. One, we are focused on the United States, and we will be launching Canada very soon. The rest of the world, international markets, will come. I don't know if that's going to be the end of this year or early next year. But for 2020, our key focus is to continue to build a network in the U.S. and to call it the 30 NFL cities, and getting those cities to be so well covered that it's comparable to cellular. We're already at 10 of those cities now where we have amazing coverage. We'd love to get it to 30. And also to really build out use cases and to really show the value of this alternative network to cellular, and showing our customers who've invested their money and time early on to build a network that there's true utility to this. And I think that's what makes everyone most excited, is that they can see that they own and operate a network, and that there's true utility to it.
So if I was going to buy one of these hotspots, what would be sort of the devices around my house that I could easily connect right away?
Today it's being built, and I would say building these devices is non-trivial. It does take time because of the different applications that are associated, different application stack and the application layers and the hardware involved. And so I would say look out for things like tracking and tracing. That is where we see a lot of demand and interest, and that could be something that we don't even think about. It could be a connected mousetrap to construction equipment, valuable equipment that contractors use for buildings, for homes, and of course to life-saving things like pharmaceutical drugs. We've got companies that we work with that are looking at how they can ensure that the cancer medication delivered to the patient has provenance, and as well as handling in the correct way so that the drug is most effective to treat patients that have that need. And so the use cases
medical
are
devices
quite
and
varied.
sensors are huge.
Right. So I think the things out there today that are testing on a network are certainly these scooters and skateboards that you see out there, but as well as Fortune companies like Nestle. Nestle Ready Fresh is a water business out of Connecticut, and they have 2 million water bottles and water dispensers in homes and businesses, and they're using our sensors to track where the water levels are so that they can provide water on demand and not have to store water, and build some efficiencies into how they truck the water over to the customer to meet their needs. To agricultural technology, a company called Agulus in South Carolina is helping farms that are doing a lot of boutique farming in greenhouses, and they're built sensors to track the environment within the greenhouse to the soil, and taking that data to help passing the data on the Helium network to really help the farmers figure out how to optimize the farming so they can produce better product and produce year-round.
That makes sense. This is a question that just sort of came to mind, and I thought you might have some insight into it. I know that there are a lot of networks rolling out 5G across the U.S. I had, AT&T come hand me a letter at my house because they were putting in a tower across the street. Do you think there's any credibility to some of the worries people have about signals at that bandwidth potentially causing health problems? And are there any considerations with long PHY that might be similar?
Yeah, well, what we use in unlicensed spectrum, 900 megahertz, has been around, I want to say 50 to 70 years. It's very common, widely used, And I think I mentioned earlier, it's very similar to sort of the radio waves you would get in nature, right? So I'm not a scientist, so I don't know if there's adverse effects. I don't believe so. I think if a technology, and certainly in this case, a public spectrum like 900 megahertz been used for that long, if there were any adverse effects into large populations, we would see that by now. And as it relates to 5G and the signal and frequencies they operate in, which are a licensed spectrum in the gigahertz space, I don't know if it's bad for you. I don't know if there's any side effects that could occur. And it's certainly at a higher frequency than our current cell phones that we put in our pockets. And so the question becomes, of all the population that has cell phones in their pockets for the last, 15, 20 years, who are the ones that have actually gotten some health, problems as a result of that? I don't know. I'm sure there's some study out there that's seen both sides of the coin. But yeah, I think it's always good for folks who are concerned about these things to do the right research and do their own research and make their own determination.
Sure. Yeah, no, I didn't expect you to have a great answer on that one. Just wanted to hear your thoughts. I figured it might be interesting.
No problem.
Since going live, what have you learned? What have been the biggest surprises that have popped up? And maybe follow that with what exciting things you guys have planned for 2020.
I think the two things we learned, one is related to how fast we can build a network like this. We didn't expect to be able to sell thousands of units of Helium hotspots and ship them in 4 months across 745 cities. I just could not even dream that we can move that fast and create a network that vast in that short amount of time. That's been fantastic. And the other thing I think that we've learned quite a lot is about the feedback from our customers, both consumer as well as enterprise or small business partners, where we made a lot of assumptions in our user experience. We made a lot of assumptions in our blockchain. And those assumptions were just sort of based on what we knew and what our perspective was. I think one thing we've learned from just the overwhelming amount of feedback, both very supportive as well as critical, is that it's very difficult to actually build great UX, great user experience, and to do it well really does take time and iteration and willingness to listen. And so we're all ears from our learning experience and just listening to our customers' feedback and understanding the perspectives of different generations, from Gen Zers all the way to baby boomers, and that their expectation of user experience is all vastly different. And the only way we can understand what they need is by listening. So that's something else we've learned quite a bit about. For 2020, to answer that part of the question, I think getting use cases and getting small businesses or Fortune 5 companies like Nestle to use the Helium network will be crucial. Crucial from a standpoint that the believers in this cause, the folks that have built the network, can see and realize that this vision of creating a ubiquitous network for IoT or Internet of Things is definitely sort of low-hanging fruit. If it was there, we would solve so many problems. And in the world of, pharmaceutical and cold chain, that's a $15 billion loss for them to not be able to deliver drugs in a correct way. And so if Helium could add value even there, that's a huge market that we can unlock. And that's just one application for one vertical, right? One problem. If we can tackle thousands of problems and thousands of verticals, I think we would unlock the promise of Internet of Things, which is like a multi-trillion-dollar business. And the beauty of all that is the people win. It's the people's network. All of the folks that believed in us and are supporting us today, they win because they are the owners of the network.
And so is that your ultimate goal, to create this sort of peer-to-peer internet experience where people can really interact with the internet without sort of a ISP as a gatekeeper?
Yeah, I think that kind of brings it back full circle about the whole idea of decentralization. In this case, what blockchain and decentralization can do to the telco industry. I think you and I, we both grew up in a world where there was one choice, whether it be for your home phone or for your cell phone, or maybe there's two choices, right? But certainly for like cable TV is one
Two
choice.
perceived choices. Yeah.
Correct. So I think, and it's been like that for 100 years. It's time for a change. And what's to say that an alternative like Helium, and a Helium network that's created by the people, could be a viable alternative, right? And could be a viable choice. I think what's beautiful about that model is the blockchain in this case is what makes it all possible. The blockchain is a universal regulator in this case that treats all hotspots the same and fairly, and allows for transactions and commerce to occur without a centralized authority. And that's sort of, I think that's what's always been really cool about blockchain to me. And being able to apply that to the telco industry and to helping everyone that participates, I think is pretty cool.
Yeah, the real net neutrality. So if you could sort of wrap up just to tell people how they can get involved, what the best things they can do to support you might be, and where they can go to follow along.
For sure. So if your listeners are interested, a lot of our open source community conversations are happening at chat.helium.com. Please go there and check it out. Doesn't matter if you're a novice or if you're not really familiar with blockchain or with wireless networking. The community members are now, I think we're over 1,000 on there, are super friendly. We love to get folks involved, and certainly folks that are new to the community are even better. So please go check that out. If you haven't purchased a hotspot and you're interested for our May delivery, go online to helium.com/store. The hotspots are at a reduced price of $350 right now compared to the $495. So get your hotspot right away. And if you're looking for a job, we're hiring. Check out helium.com/careers. I think that's the right URL. If not, just go to helium.com and click around. It's on there. We're hiring everything from developers to sales. So if you're into innovation and you're motivated and you're energized to see the telco world become decentralized, look us up.
Well, that's a great place to wrap. Thank you so much for coming on the show. I encourage all of you guys listening to check them out. They've got some really great stuff, and download the app and see what it looks like to build out a hotspot and buy one if you're feeling like it. So thank you so much for coming on the show, Frank. I really appreciate your time, and we will be back next week with a show from Ocean Protocol. So thank you guys for listening. As always, we'll be back soon with more.